Okay, in this assignment there are 3 little problems to do. This is the first of the 3. It said, I think, convert theta to radians, find the length of s, and find the coordinates of p. And so we're going to try to do this one little piece at a time. The easiest thing to do, I think, is to convert theta to radians. We're going to do this the way we always convert things. We start out with the answer we have, which in this case is 22 degrees. And I always want to multiply by a fraction. Now when we're converting things with a circle, remember I want a lap on bottom, a lap on top. Now what am I going to put on the bottom? A lap in degrees, because I want the degrees to cancel. So this is just going to be 360 degrees like that. Now a lap on top, is it going to be in radians? Now in radians, 1 lap is just 2 pi all the way around. So I'm going to get that. You can see that the degrees are going to cancel like that. And all that's going to be left is going to be 44 pi over 360 degrees. Yeah, that's it. 44 pi over 360. And remember, I'm sorry, the degrees are gone. And I get like this. Now I'm going to put this answer at the top. I want to check myself just for a second. Now 44 times 3 is about 130. 130 over 360 is about a third. Now is it true that this is a third of a radian? Well, I know in radians to go from here to the very top is about 1.6, to go halfway is about 0.8, to go a quarter is about 0.4. Now, it looks like my picture is lying a little bit, because 0.3 should be down here someplace. But it's at least reasonable, and that's what I'm going to do. I'm going to write that. We've at least checked it. So this is going to be 44 pi over 360 radians. Yay! Okay, so we've at least converted to theta. Now what about r? R is really easy because the definition of the radius is the distance from any point on the circle to the center, and we can see from here to here is 0.05, right? So over here I'm just going to write down that r equals 0.05, and that was a big gimme, which I like a lot. Now the next thing I want to find, I think, is the arc length. Now remember, this is a teeny tiny circle. The radius is 0.05. All the way around is really tiny, so I'm expecting a very tiny answer. How am I going to do this? Well, I'm going to start with what I was given, which is 22 degrees. And I want to multiply by a fraction that gets rid of the degrees and gives me arc length on top. They didn't tell me what units I have of arc length, so I'm going to have to leave it out, but I don't like it. Meanwhile, I put a lap down here in degrees. Remember, that's so the degrees will cancel. And on top, I want a lap of arc length. A lap of arc length is 2 pi r. So this is going to be 2 times pi times r. Let's see here. The degrees cancel, which is great. That's what we wanted. I know that 2 times 0.05 is 0.1. 0.1 times 22 is 2.2. So I'm going to get something like 2.2 pi over 360, which as promised that's a teeny tiny number, but I'm just going to live with it. So s is going to be 2.2 pi over 360, like that. Yay. Now the other thing I think is that they wanted the coordinates of p, and at the moment, well, okay, what I'm going to do is use reference triangle. You don't have to do this, but I want to do it just to reinforce where they came from. So I'm going to draw a little reference triangle here like this. Now remember, to plot the point P, you had to go over x and up y, so I'm going to call this xy. Like this. And I'm going to use the reference triangle in trig. Now how am I going to do this? I'm going to label this x. I'm going to label this y like this. What trig function can I think of that involves the x and the radius? Well, it's the trig function that involves the adjacent and the hypotenuse, and that's cosine. So what I'm going to do is I'm going to write down that the cosine, and they gave me it in degrees, I'm just going to leave it like that, right, is equal to the x coordinate that I want over the 0.05. Now when I solve for x, watch what happens, right? I'm writing x equals the radius, that's r, times the cosine, like that. Cosine 22 degrees, and so we just get x equals r cosine theta. Finishing up, I'm going to go to the reference triangle again. I want a trig function that involves y. Well, the trig function that involves y is going to be the opposite over the hypotenuse. And that's sine. That's our definition of sine for a triangle. So I'm going to write down that the sine of 22 degrees is equal to the opposite, which is y, over the hypotenuse, which is 0.5. And when I solve for y, I multiply both sides by 0.05, which is the radius. And so what I'm going to get is y is equal to the radius times the sine of the angle. Now I can put the numbers in, but at least we've actually solved for everything.